Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question, raw and uncut. So we have a medium today. Well, it's actually from yesterday. So we have zero array transformation 1 or 2, I think, but today we have 3. So yeah, let's see what it wants. So we're given a nums array of length n and also queries, which is a range of index, I think. Well, I think it should be the same as yesterday, right? So yeah, so we have like 100k length for nums, and then for queries, it's also 100k length, and each of them represents some kind of index range inside our nums. So each queries represent the following action on nums. So either we can decrement the value at each index in the range L to R in nums by at most 1. The amount by which the value is decremented can be chosen independently for each index. So a zero array is an array with all its elements equal to 0, and we want to return the maximum number of elements that can be removed from queries, such that nums can be converted to a zero array using the remaining queries. So we want to see how many queries we can get rid of. Until we want to see how many, like, the maximum amount of queries that we can get rid of, such that the queries can still turn our nums array into a zero array. So if it is not possible, return -1. So yeah, let's look at some example first. So if it is 202, we can remove queries 2. So we can remove this one because these two should be enough to turn these into into zeros. So yeah, so that makes sense. And then for this case, so it actually says 2 because like we can remove these two. I think that's what it's saying. And these covers 1-3 covers these, and 0-2 covers those. So yeah, it's actually very similar from yesterday's question. But then we have to find a way to quickly we have to find a way to quickly decide like which queries we can keep and which ones we don't need anymore. So yeah, I think like for this one we might have to do a bit of drawing. So I think like for the let's say for 1 I think that's a good case to use. So we have like 1-3, I think 0-2. Is it 1-3 again and 2-3? I think. So if we have something like this, again, I think we have to sort our intervals. So, and I think we should sort based on the start. That makes the most sense, I think. Yeah, so I think like so yesterday's so for yesterday's question, what we did is like we have like these sorted intervals, and then we have like the active and array thing, right? So like for example, like for 0 we'll get 2 here, so like we have a 2 here, and then so that means like that will be satisfied, and then it will be satisfied because we have like one active range. So yeah, and then we can like look at the next one. So, and like obviously if we look at the next one, we have to like add these in, right? So this is just a recap like for yesterday's one. So we have 3 and 3, so that works. And then when we go to this one, we have to pop the 2 out because, well, 2 is no longer. Oh, actually, no. Yeah, this is 0 index, so we should actually add this. So we have a 3 here, and it's only when we get to here that we pop the 2 out. Yeah, and then like obviously we can satisfy everything here, right? But here we have to find ways so that we can find the redundant ones here. So I think what we should do is so if we have redundant ones, we should like store it in like maybe a potential redundant array, or well sorted list, or whatever data structure is there. So yeah, honestly, like I'm not too sure exactly how to do this question yet, so I'm still like playing around with it. So like let's say we have like a redundant. So active, and so yeah, for the first one, well obviously we have to add these intervals in, right? Well, we have to add one in because well if we don't, well yeah, if we don't, then like for example, like for the zeroth item, if we don't add 02, we literally can't solve it, right? Like we we can't turn the first element into a 0. So we have to add that. When we go to 1 here, so now we have 2 choices, right? Like we have 2 more choices that we can add. So we have, yeah, actually, how big are the elements? So they are from like 1 to 100, or 0 to 100k. Yeah, we also have to account for like the 0k. So like, so for example, if this is 0, I think like what we'll do is we just skip that index, and it'll work. Yeah, but anyways, let's get back. Yeah, another thing is, if there is a, so let's say this is like 1 1, and that's 1 3. Well, what we want to do is we want to use the larger one first. So we want to use this first. Well, because like if you think about it in the greedy way, well, choosing the like 2 intervals with the same start points, so they're both 1 here. If we choose the larger ending point, it will always be better than the smaller one. So actually, maybe what we want to do is we want to sort it based on the start, and then the negative of endpoint. So if we have the same starting point, we will tie break with whoever has the larger endpoint. So here we'll add 3 in. Well, we know that we definitely need 02, right? So yeah, so we can add 3 in, but well, as we see here, we already have we already have 1 active here, right? So that means like we will just add all these into redundant. So 3 and then 1. Yeah, I think we can use a sorted list or something like that here. So just do that. And then when we get to the second one, well, we want to add this interval in, right? But again, we can just add it here. Yeah, and then when we get to the third, Well, actually, we have to get rid of this now. Yeah, I guess like we will have gotten rid of this, but since this is only in the redundant thing, we can I think like we can have a store. So this would be like the number of like redundant stuff. So like because we have passed um we have passed one but we have never used it. That means we don't actually need that, right? So we can just yeah, we can just add that. And when we get to 3, well, here we actually have to use one of these intervals now because well, this is 1 and like obviously is like we need something in our active thing. So we remove that, and then so that works. And then after we finish, we still have like some redundant ones that we didn't use. So like it will be 2. So I think like that's how you get the number of um redundant queries. And of course, like if you have a 4 at the end, then um well, like even if you add both threes there, the active n is still like the number of active intervals is still smaller than the current number, so we can just return -1 in that case. So yeah, I think that's how we code it out. Yeah, also a viewer asked to code in some other languages, so I'll do it in C++, which I haven't done for a very long time. So bear with me if I have to like search up any methods and stuff. So yeah. Um so of course we want using namespace stud. Yeah, I don't remember the all the include stuff honestly. I think it's like include iostream. Yeah, honestly, like LeetCode has the import stuff automatically done for you. So, yeah, maybe I should focus on coding out first. I am a bit nervous writing C++ because I haven't written it for so long. But yeah, so what do we need at the beginning? We need a we need to sort our factor. Yeah, actually I think we don't even need to we don't need to sort like based we don't have to tie break based on endpoints because like we will add all of those in anyways. But it's just that yeah, let me quickly get back to this, right? It's just that like when we have a 1 and a 3 in redundant, we actually want to choose from the back instead because like this is the larger interval, right? So I think like that's the only difference that we really should make here. But yeah, otherwise it should be the same. So we want to sort queries. Wait, so queries are factor int. I'm not sure if they are comparable. We will see. So we have nums here as well. So yeah, we want int. So that would be the number of redundant. Yeah, no number of redundant. So we set it as 0 at the beginning. We also need I think we need a multi set. So I think this, or maybe just set. We would do that for now. So yeah, we also need the. Oh, isn't this how you write comments? Okay, whatever. Yeah, so we need a multi-set for the maybe a priority queue works as well. But I remember like in C++ you have to um let's just use a multi-set. Is easier, I think. So multi-set int, I think. Yeah, so active, and then we also have a multi-set. So the reason we need multi-set is like for a normal set. Yeah, maybe some of my viewers are like only Python, so I'll also try to explain a bit of C++. So for the normal set, it is somewhat like a sorted list in Python. So it is sorted, and also like you have log n, add, and removal. If it is multi-set, it basically allows duplicate elements. So this will be like closer to what a sorted list is. So we also have redundant. Yep. So now what we want to do is we want to go through each of the numbers. So for int I is equal to 0, so nums.size. So we just want to go through each of the numbers. And also here what we need is yeah, actually what do we need to do here? I think like what we can do is we can add all the intervals. Like we can add all the and into redundant first, and then we move it up. I think that will also work. So so I guess we need an index for like which query we are up to. So while I think like queries q index. So to get the start, I think that's how we get it. So 0. So while the start is equal, I guess like, yeah, I guess we can do equal here because we'll go through like each of the index. So while that's equal to I, we can add that into redundant. So redundant insert, I think, if I'm not wrong. So we want to add the end interval in. And then, so we want to increase our q index here. So redundant. Okay, what else do we need now? So after we have done that, we will have like, so if we go back to this case, we will have added two, well actually in redundant now, because like now we can like gradually pop it up. So so for int j is equal to 0, well wait, what can we do here actually? I think we would do like int j is equal to nums I. So that will get the number, like that will get the number of intervals that we need to be active. I guess we can do like minus like active size, because like those are already in there, so we can just add those in as well. Yeah, so you just want to do, I guess, like while j is not equal to 0, we want to pop the redundant, we want to pop the largest redundant interval in there. So but well, we also have to check. So if redundant dot size, so if it is empty, I'm pretty sure there's an is empty method, but let's not use that for now. So once you return -1 here, because like we literally can't add any more intervals in. But otherwise, what we can do is we can do auto it. So we're actually end. So redundant dot end. So that should get the null pointer at the end of the multi-set minus we can like just decrement like this, I think. Maybe I'll just call like an iterator. And then we do something like redundant erase and iter. I think that's how you do it. Yeah, we also need to like get the actual value. So in endpoint, so I think that will just be dereferencing and iter, and it will get you the actual value. Redundant erase, and then we have to go to active, and we need to insert that in there. So yeah, so we want to insert endpoint there. Yeah, so I think that's what we need to do. We also need to get rid of all the expired endpoints, and I think we can do it here. So while we only check from the front this time. So while active dot begin, so that should get us the value. If it is smaller than I, well, we can again, like we need the iter. So we want to remove this, right? So active dot begin. I guess what you can do is just do active dot erase, active dot begin. So we'll get rid of the first element like this. Yeah, but we also have to check active dot size is larger than 0 first. And then we need to do the same thing here for redundant. So I think that's all you need to do. Well, I'm extremely not confident this is gonna work because I haven't written CPP for so long. Yeah, actually for here, if we are erasing from redundants, we have to add to our number of redundant things. So num redundant. So here it will be redundant, and also like all the ones that we haven't gotten rid of. So redundant dot size. Okay, let's fix all the bugs now. Surely there are like a million of these. Set. I think it is set for multi-set. Oh, yeah, that's what I don't really like about C++ is when you get these buffer overflow stuff. But yeah, I think it should be maybe we have to limit the we have to limit Q index so it doesn't actually go past the queries, I think. Oh, okay. So it printed -1 here. That means it has got to this point here. So I guess what we want to do now is we want to print out like what is actually is it just printing -1 for all of these? Yeah, okay. So it seems like we are not adding the redundant stuff incorrectly. Yeah, that's what it feels like. So I guess like we're gonna do like for, I think it's like cons auto eggs redundant. I think that's how you print them out. Okay, so let's see like for each stage, are we actually adding the correct stuff in, or like where it is actually wrong? Yeah, okay, so we added this correctly, so I know what the problem is. So when we actually like move that across, like when we move something from redundant to active, we actually have like one less thing here, right? So so we want to like do, like we need to decrement J. We got this case working. Yeah, so let's look at this case. Why is it still not working? Right, so this is so we actually got to the second number, I think. It could be like some zero stuff being wrong. Larger than 0. Surely that's the issue. Because like I think what's happening is this is, for index 1 this is 0, right? But then we already have like two. We already have one thing. Well, actually two things in active.size, because like we will have need both intervals for the first two here. So this would be like -2 or something. So we actually need like we can't use just equal. Yeah, let's just run it first and debug. Yeah, I'm not confident at my C++. I think I haven't written. Oh, okay. I haven't written C++ in like maybe 2 months. So yeah, I'm glad I don't have to search anything up for this, which is very amazing. Yeah. So let's think about the intuition on like how I solved the problem and how I got the intuition. So if you have watched yesterday's video, or if you have like done yesterday's question, you would know that like you know how you can like sort the intervals and use active end to check how many active intervals are for the current number, right? So another thing to notice is that like if you have 1 1 and if you have 1 3, it's always better to choose 1 3 because it has a longer interval and they have the same starting point. So I think like with those two things in mind, you can check whether an interval is actually used or not. So I think like that's the main thing that you have to see. And yeah, otherwise it is just like modifying from active end. So yeah, it is just modifying from that. And then like for redundant, if you never get to add that into the active intervals, well, like for example, if you have a 1 here, but you already have like enough intervals up here, so you never actually get to use it. And when you get to the second element, you never actually touch that interval. So yeah, so that means that would be a redundant interval. And because we are picking from the end, we are greedily adding the largest intervals into our active end. So that part is optimal, and we can't do any better than that basically. So yeah, this is kind of like a greedy interval question. And like, of course, you can just store the number of redundant intervals that you got rid of, and you'll be able to solve the question. So yeah, I think this video has gotten a tiny bit too long because of me writing C++. But yeah, if you want me to do it in any other languages that I know of, I think like for now it's probably C++ or Python. But if you want me to do it in any other languages, just leave a comment below, and I'll try to do it if I can. But if I can't, then yeah, I'll just do it in C++ or Python. So yeah, thanks for watching, and I'll see you tomorrow. Bye.